Welcome to Get Your FRQ On. This is from the 2004 exam, Form B, question number 4, and it is not calculator active. In the question stem, we're provided the graph of f prime of x and not really much else. There's a little bit of information about the graph. It has a horizontal tangent line at x equals 1 and x equals 3. But we are asked to find the x-coordinate for each point of inflection and to justify our conclusion. So in the question stem, we're really only provided the graph of f prime of x and a little bit of information that we're going to use in the other parts of the question, but nothing about the second derivative of f, which we would like to know in order to find the inflection points. So the issue here is that in order to make a conclusion about the graph or the function f of x, we have to be able to justify our conclusions using only the given information. In this case, the given information is pretty much just the graph of f prime of x. So we have to take what we know about how to do this with calculus and interpret it through the lens of f prime. Right, so the graph of f will have inflection points whenever the second derivative of f is equal to 0 and also changes sign. The problem here is we don't really know much about the second derivative of f other than we have a graph of f prime, and maybe we can use some information from the graph of f prime to reach our conclusion. And that is actually what we have to do. We have to make our conclusions based on the graph of f prime in order to properly justify them, since that's the only given information that we have. So in terms of f prime, in order to determine where f has an inflection point, right, well, f double prime has to be 0 and it has to change signs. Well, okay. We can do that with the graph of f prime if we can identify where f prime changes between increasing and decreasing. Right, well, we have the graph of f prime, so we can identify those points from the graph. We're also given that it does have a horizontal tangent line, f prime does, at x equals 1 and x equals 3. So, based on the graph of f prime provided, f of x has inflection points at x equals 1 because f prime of x changes from increasing to decreasing, and x equals 3 because f prime of x changes from decreasing to increasing. So that's how we can tell where f will have an inflection point given only the graph of f prime of x and a little bit of other information in the question stem. In part B, we are asked to find the absolute maximum and absolute minimum of f on the interval from -1 to 5, and to also show the analysis that leads to our conclusions. All right, well, the graph of f will have an absolute maximum either at an endpoint or somewhere in -1, 5, where f prime of x is 0 and changes sign from positive to negative. Likewise, the graph of f will have an absolute minimum either at an endpoint or somewhere in the interval -1 to 5, where f prime of x is equal to 0 and changes from negative to positive. Right, well, based on the graph of f prime, which is one of the only things we're actually given, the graph of f is decreasing from x equals -1 to x equals 4. That's because on the graph of f prime of x, all the values between -1 and 4 are negative, so we know that f is decreasing there because f prime is negative for all of those values. Also based on the graph of f prime, the graph of f is going to be increasing from x equals 4 to x equals 5 because the graph is positive for those values of x. So we can use this to conclude that the absolute minimum value for the function f will occur at x equals 4. All right. There's nowhere else where f prime of x is equal to 0 and also changes sign. Right? So the absolute maximum must occur at either -1 or 5. Right? It can't happen anywhere in the middle. The only place in the middle where f prime was negative was the minimum. So there's not going to be another one. There's not going to be a maximum anywhere in the middle. We don't have the required derivative property there. So in order to compare f of -1 and f of 5, in order to determine which one of those is the absolute maximum, we have to find a way to actually evaluate f of -1 and f of 5. We can do this using the fundamental theorem of calculus. The integral from -1 to 5 of the f prime function t dt, by definition or by the fundamental theorem, is f of 5 minus f of -1. Okay, but this is often rearranged in order to calculate function values. I can rearrange that equation and say, well, f of 5 is then f of -1 plus that integral, right? The integral from -1 to 5 of f prime of t dt, right? If you look at the graph of f prime of x, it's pretty obvious that the integral from -1 to 5 of f prime of t dt will be negative. All right, almost the entire graph is below the x-axis, and only a small portion of it is above the x-axis, and it's not really that far above the x-axis. So most of that integral will be negative. You're not going to make up much when it becomes positive. So the integral from -1 to 5 of f prime of t dt should be pretty obvious that that's going to be negative. Well, if f of 5 is f of -1 plus a negative number, it stands to reason that f of 5 is less than f of -1, because in order to get to f of 5 from f of -1, I have to subtract something. All right, so we can conclude that f of 5 is in fact going to be less than f of -1, and therefore that the absolute maximum value of f is going to occur at x equals -1. In part C, we are defining a function g of x to equal x times f of x, and we are asked to find the equation of the tangent line to g at x equals 2. Well, in order to do this, I have to know a couple of things. I have to know g of 2, and I have to know g prime of 2. All right, well, g of 2, I should be able to figure out. It's given in the given information that f of 2 is 6. I can find an equation for g prime of x by differentiating x times f of x using the product rule. Right? So I have a general rule for g prime of x, that's x times f prime of x plus f of x. And now we can determine g of 2 and g prime of 2. Right? Well, g of 2 is 2 times f of 2, which is 2 times 6. That's 12, right? So g of 2 is 12, all right? And I can also find g prime of 2. G prime of 2 is 2 times f prime of 2 plus f of 2. We're given from the graph, it's actually one of the points on the graph, that f prime of 2 is -1, so I can directly substitute in -1 from the graph. So g prime of 2 is 2 times -1 plus 6, which is 4. So now I know that g of 2 is 12 and g prime of 2 is 4. So the tangent line to g at x equals 2 is going to be y minus 12 equals 4 times x minus 2.